All right. This is our project for database theory and design, our final group project. We've chosen Venmo as our project, and this is being presented by Joe Cecchio, Joel Manwaring, Dominique Romero. So as we go through this, I'll be presenting the first three pieces: the company, the product, and the business requirements. Joel will be going over the modeling, and Dominique will be taking us through a SQL demonstration. And these two gentlemen in the picture are the founders of Venmo, and they have complicated names, but Dominique knows how to say them.
So the first individual is Ingram Magdon Ishmael and Andrew Cortina.
Yeah, those guys. All right, next slide. So the two founders went to UPenn, and that's where they kind of came up with the idea for Venmo. Venmo was acquired through a couple people, and you can see there was huge potential in them as they turned from a $26 million company to an $800 million company. They're now currently owned by PayPal. And their slogan is to connect the world and empower people through payments. So what does Venmo do? Most of us know of them as a place where we can send money from one individual to another individual, typically from one's bank account to another person's bank account. They do offer some other services where you can actually send from your credit card, and we'll walk through some of these features as we get further in the presentation. It's also a very social environment where you can comment and like, and you have friends, and you can see history and other people's history as well, where they've been sending money and who they've been sending money to. So how does Venmo work? This is kind of why we picked Venmo. Each of us on this group, we use Venmo often. So click through, Dominique, so I can see. Venmo allows you to actually hold a balance in your Venmo account. You're also able to obviously transfer directly from your bank account. In addition to that, the service allows you to request funds from someone else. You can also, I think they call that charging. You can Venmo charge someone, and then obviously you can also send money, pay someone. And they've handled tons of transactions since 2016, and they continue to grow into this year. So as we developed our models, before we did that, we came up with the requirements for the business just based on things that we as users of the app need to be able to do. So we've listed some of those things. The main ones, of course, are transferring from bank accounts to other users. And then we've listed some other things that the service does as well. So Joel, if you want to take it from here on the modeling.
Thanks, Joe. We're going to start off with our conceptual model, which is just an entity relationship diagram. And when we started out, we kind of focused on the user entity, which is in the center, slightly to the left. And as you can see, we've got a couple different groups of entities and relationships going on. In the bottom left, we have basic information about each user that might be useful. And then on the top half of the user entity, we have things like a friends list, balance that are owned specifically by each individual user. We also have a relationship between the external bank and card accounts that are shown by a disjoint relationship over on the top right. And the kind of the bulk of this project was spent on making the transaction entity work in harmony with the user, as well as the different banks and cards, and also the Venmo balance, which was a little bit tricky, but this is where we started. And we can move on to our logical design. After we had started designing our tables, we came to the conclusion that we should probably specify which type of transaction is being processed. And we have 3 different fields. We have card ID, bank ID, and balance ID in that transaction, and those can be null, but also could be populated depending on the type of transaction is being processed. But most of this is pretty self-explanatory. The underlying values are either primary keys or foreign keys referenced by another table. And we can move on to the physical model, which is what will show those specific foreign key relationships a little better than that model. So in this physical design, we can see how these different sort of columns are connected across different tables. And this is the final design we ended up building in SQL, and Dominique will actually show us what we ended up with.
All right, so before I get into the SQL, thanks, Joel, appreciate that. So some future features we're working on or still want to work on is live updating of a transactional record to alter the balances. So that would be if a user makes a payment from their Venmo balance, it would automatically deduct that balance. And also, if they receive the payment, it would update that balance as well. Part of that we've tried to implement in this first go around in the first set of business requirements. We weren't able to get it completely done. So that's still a work in process. The next thing we want to work on is an enhanced friend list. But let me go ahead and get you over to the SQL and we'll kind of walk through that real quick. So as you see here, we have just an SQL table. It has hundreds of lines. So I have it just in case we made a mistake, I can start over again. So I'm going to go ahead and run this for you. And as you see, it's running through each statement. When we did this, sometimes errors would pop up. We'd go address those errors and fix them individually. While we're waiting for this to run, you can see we inserted quite a bit of data into this these tables. So now that is finished, let me go ahead and get you over to some queries to show you that that data actually worked. So from here, I'm going to show you what the user table looks like. And here in the user table, you'll have a user ID, the first name, middle initial, last name, street, city. You'll have the state, zip code, phone, and email address. From there, as you see, we have 120 users in the account. We just built 5 transactions to make sure that the concept worked. And let me go ahead and run that transaction table. So from here, like Joel explained, you could have a null field in the bank ID or balance ID depending on what it was. So transaction 1 here was from user 111 to 230 for the amount of $942 using a credit card for shopping, and that was made on September 8th of 2017. In the status column, you'll see C for completed. That means that the transaction is complete. If we're looking at number 2, so number 2 is actually a request. You can tell that because the card ID, bank ID, and balance ID are all blank. So user 112 is requesting $8 from user 229 for lunch. So they must have went to lunch and somebody paid and the other person owes them some money for it. And you can tell that also in the status column is request. Once we're done here, once user 229 actually completes the payment, they would choose whether they use their balance, their bank, or their credit card. It would update that field in there with the correct corresponding number, and then it would also change the status to complete. If you take a look here, is our credit cards. You have a card ID, which is tied to a user. Now in here, just to show how this database is working, we use one card per user. Obviously, some users could have multiple cards, but you would have the card ID, the user ID, the card number, expiration month, year, the CCV code, and also the zip code. And you may be wondering why we added zip code in the actual card table. The reason we did that is because it may be different than the shipping or billing address, just depending on what cards and how many cards people use. We also used a bank account. For bank information, that was a pretty simple table. That's just your bank ID, what user it's associated with, and then the routing number and account number. The balance table, you have the balance ID. This would be used for when you're making payments with the balance, so it would go in the transactions table. The user ID, which user has the balance and the balance now, and then the transaction ID. And you notice all of them are null except for number 4 here, because in a transaction table, I'll show you here in a moment, it'll show you that you saw earlier they paid from a Venmo balance. So that's reflecting back to that. And that's where we ran into the problem is with our foreign and primary keys, how to get that to match up. So that, like I said, it's still a work in progress as far as that goes. And then here you have just a friends list. And you can see user 135 is friends with all these people. That's just a basic table for that. And like I said, we want to enhance the friends list and how we use it. So I'm going to run through a couple of queries. This selects all. This next query we run is going to select transaction amounts that user 230 has requested or received in chronological order. So if I run that query, it would show it was the first transaction for $942. It's been completed. The next query is lists all comments for transactions over $20 made in the month of September and order by descending amount. So if we run that one, it shows there is for shopping that was over $20 and for transportation that was only over $20 made in September for those two amounts. So the next one is emails, an email list of users that have credit cards expiring before 2019. So it responds with those two there. And then our last one is part of where we want to enhance our friend list is if I run that. So this is just running the user IDs that Christopher Johnson has as friends. So he has 5 friends on there. Like we said, we want to just enhance that part of it. So that's what we did through the SQL part. It was actually a great experience from start to finish. I think Joel and Joe can agree with me that we definitely learned a lot in this just from how to organize a database and enhance a database, and coming from the entity relationship diagram to the conceptual model, some changes happened. And then when we got to our physical model, actually deciding how to lay it out, some changes happened. So that is our presentation, and thank you for taking the time and listening to us.
Yep, thank you.
Thanks.